video, we'll be learning about denormalization and normalization. So, yeah, in the previous video, also I have been discussing about denormalization for the one use case. Which use case I was talking about is like read heavy databases. We try to implement denormalization so that we try to reduce the usage of joins, and we do the single line query or whatever, we do the single query without joins, and so that the read happens very fast. So the same thing we shall learn somewhat more about that itself, like it's a very easy topic here. So yeah, 1 second. Let me make it small. Yeah, fine. So now if let's see about benefits of denormalization, right? First thing first, faster reads, because no joins, obviously. See, in this, if you see here, if you want to find find the name, find the row with name, sorry, or what we can say, yeah. So if you want to find the name of the person, or what we can tell, yeah. So if you want to find the name of the person, or if you want to find the country tax, and whatever, if you want to find something which include joins, so if you want to do something there, so in the first table, if you see, everything is there in the single table. In the second, if you see, they are divided into two parts. So whenever you are reading, if you reduce the joins, the first table will be easier. Whenever you are writing, let's say you want to write only name, not state tax or not country tax, in that case the lower two are very useful, right? You will use only the smaller table, and in that you will be trying to write. So here this makes the difference. So one more benefit is that simpler query, better scalability, reduced databases. Look, yeah. So first thing is that better scalability. See, let's say we are having two tables having some relation between them. Like this here, if we see, uh, here ID, here ID is the relationship between them. So if we take these two tables, and whenever we are scaling, and scaling means like, uh, let's say this table, this server can fit only this much of data. So we need to keep one more server, and in that we'll be having these two tables but with different data. And whenever we try to do some join on that, so what happens in this table, there might be a situation where we need to join the rows from this table with the same tax status rows from the other table. So there is a network partition here. So there will be many other things coming in between, and this causes very huge latency and very so much time. So this whatever normalized form is there, that doesn't fit for the scalability thing. And did you about, if we see that database load, yeah, obviously the same, right? If there is too much of database load, obviously the latency will decrease. So it's almost like faster reads only. So one more thing here, let's talk about the trade-offs. Trade-offs, if you see, data redundancy is increasing if we use denormalized form, obviously, and updation, obviously, because you need to do many writes there. And what else? More storage. And one more thing is potential inconsistency is also. What is this potential inconsistency? How is this coming? So let's say due to denormalization, and we might have this scaling also. So let's say we will be having data, too much of data at multiple places, and for one write request, there might be the situation where in normalized form we might update only one row, but the same in the denormalization form leads to updating multiple rows. During that time, let's say in between those two updates or multiple updates, if there is a network issue, or one more thing is that as it is a denormalized form, it is good in scaling, and if we are trying to update uh, the rows between two different servers, and if one server crashes, only it updates in one server, the other server is not updated. So this is what we call potential inconsistency, right? And whatever else is there. So now we will try to learn when to use this denormalization. Obviously, first one thing will be used during read heavy workloads. Read heavy workloads where 90% reads are there, and where we are having slow joins, and where data doesn't change frequently. That is obviously what the first point says, right? And what happens? Even consistency first thing. Consistency, if you see what is happening here, read heavy workload. In read heavy workload, what might happen about consistency? In this thing, consistency can be eventual. That is what we call as potential inconsistency. That is what leading to potential inconsistency, right? Because there will be multiple writes. That is what not everything is updated. Query patterns are well known, that is obvious. So what we do is like initially we need to start normalized way, like we will be having many tables, and then we will measure the performance. If the performance is not what we are expecting, and then we try to denormalization according to the business needs. But just don't directly use the big table, only one table like this thing. Okay, yeah. Let's say a social media feed shows the username on every post. To avoid joins, what we want to do. So we will store the username directly in the post table. This is what we call as denormalization, right? And let's say workload benefits most from denormalization. Which workload? Which workload? It is read heavy, obviously. So that's it for this video. We shall see in the next video. Thank you.